I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider a very important topic for GCSE students. It is change subject. Many of us treat this as isolate variable. The questions taken in this video are from previous test papers and they will help you practice for your exam. In case you want to learn from me, you can always send an email on the address given. Now we have 4 questions here in which you need to change the subject, and these are important exam practice questions. All of them, as you can see here, are quadratic equations. So we will learn strategy for changing subjects when a quadratic equation is given to us. In question number 1, the equation is h equals to minus 5t minus 3 whole square plus 30. Make t as subject of the formula h equals to minus 5 times t minus 3 whole square plus 30. We'll take up this example, understand strategy to solve such questions, and then question number 2, which is very similar, is for you to practice. So we have minor changes here. I hope with these strategies learned, it won't be difficult to answer question number 2 for you. But in any case, if you have any difficulty, you can let me know on the email address given. I will be glad to help you out. You can always send an email on this address. You can also join my classes to learn more. Let us continue with the solution. Then we'll take the second variety when the equation is given in standard form. So make t as subject of the formula s equals to ut plus at square. Well, I haven't used the word half here, but you could use half at square, but I just modified a formula which is well known to you. So you need to change the subject in this particular case. Question number 4 is for you to practice. Perfect. So let's begin with solving these questions. Let me also remind you that earlier we had these questions, right? So I hope you've done those. Those were simple. Normally, from year 7 to year 9, you get such questions. Now this question, which I've taken up now, is slightly more difficult. You normally see it for year 10 and 11 students. So I think we can do for half at square. So let me just change the question here and make it half at square, which is indeed the standard formula. So I change this question to s equals to ut plus half at square. More useful for you, correct? Okay, so we'll work on this. Let's begin with solving the very first question now. So as I was saying, you need to make t as a subject for the formula h equals to minus 5 t minus 3 whole square plus 30. That means you have to isolate t. How can you do that? This equation is given to us in which form? This is the vertex form of the quadratic equation. Now if that is the form, you can do reverse calculations. To isolate. the variable t. Reverse really means something like this. We'll actually work out details, but let's understand the strategy part first. As the key idea here is to explain the students what they really need to do and why. Once you understand this strategy, it can be applied over and over again. Okay, so let's try to understand what is going on here. So, t minus 3 whole square is first thing which you are going to do. Multiply by minus 5 and then add 30 to get your result, which is height in this particular case. Now to get t, reverse calculation will be start from back side. That is, you can begin from the reverse side. Correct? That is the reverse calculation. So that means you have to first take away 30, divide by minus 5 and then square root. Now in such cases, we know that t is greater than equal to 0. So in case you do square root, you have to take the positive values only, right? Okay. So the operations involved will be reverse calculation I've written here. It really means what? Reverse calculation will be take away 30, right? And once you do that, so this is the first operation. And then you have to divide by minus 5. And then you have to square root. And that is how you will get what t is. So we have fed in the height itself and done the reverse calculation to isolate t. That is what it really means. You get the concept, right? Now let's do it. So as I was saying, we have to do reverse calculation. So let's write down the formula first, which is h equals to minus 5 t minus 3 whole square plus 30. So first let's take out 30. So take away 30 will give us h minus 30 equals to minus 5 t minus 3 whole square. And now you have to divide by minus 5. So we get h minus 30. Divide by minus 5 equals to t minus 3 whole square. And now we need to square root. So we have square root h minus 30 over minus 5 equals to t minus 3. And as you can see, it is now easy to isolate t, and we can write t as equal to, taking 3 on the right side, 3 plus square root h minus 30 over minus 5. You get the idea. So we have isolated t in this particular case. Perfect. So I hope all these steps are absolutely clear and you are in a position to answer second question. Perfect. So apply this strategy, which we are calling reverse calculation. Now let's take up the third question, where we need to modify and do a lot of stuff. So I modified this question to s equals to ut plus half at square, which is a standard formula, and we will take t as greater than equal to 0. Now this is a different quadratic equation. How do we solve such an equation? Now for solving this problem, we need to apply a method which is called completing squares. Now completing squares will lead to the vertex form. And then you do as you did in question number 1. You get the idea. So that is what the strategy is. Now let us see, how do we apply the completing the squares method and isolate t in the given situation? Let's begin by writing the question itself, which is s equals to ut plus half a t square. Let us rewrite this equation in standard form, that is to say that highest power first, as normally we do with any polynomials. So I'm writing half a t square first, followed by ut, right? That is commutative law of addition also. You can apply here. Now this is a very important step in completing the squares, and that is we'll factor out the coefficient of t square. So we'll factor coefficient of t square. The coefficient of t square is half a. So you're left with t square. When you do that, you have to multiply this by 2 over a ut, correct? Very important step in factoring. Now the next step is we need to complete the squares. So I hope you remember the formula. What is a plus b whole square? Now a square plus 2ab plus b square is the expansion of this formula. So you notice that the central term is twice the product of a and b. So taking half of this value can help us make the expression in the brackets a perfect square. So that is the strategy. So we'll write this as s equals to half a t square plus 2 by a ut, and we are adding, since we want that, as b. Do you understand? So b is half of the coefficient of this. So half of this will be 2 gets cancelled, u over a, right? We need to square this. So that becomes the b part. And you cannot change, so therefore we add and subtract the same thing. Now you can see that the trinomial we have can be written as a perfect square. Since a is t for u, b is u over a, and twice u over a times t is the central term 2ab, right? And therefore, we can write this as s equals to half a, and within brackets, we have t plus u by a whole square, and this is minus u square over a square. Do you see that? Now this is a very complicated step, and therefore this type of change of variable or isolate variable questions normally we see for year 9 to 11. So you see that we have done the completing the squares. Now let us open the bracket and distribute half a with the two terms inside the bracket. Then we can write down our formula, which will be in vertex form. So here we get s equals to half a, and within brackets the first one was t plus u over a whole square. Correct? And then we'll multiply half a by minus u square over a square. Minus half a times u square over a square. So a will get cancelled, and therefore we could write this as half a t minus u over a whole square minus half u square over a, or you can say 2a in the denominator. Do you see that? That is how we get our equation. And now you need to make t as a subject. Now this is the vertex form, right? So that leads to, so after completing the squares, we get the vertex form. And now you apply the strategy learned in question number 1. Perfect. So you'll bring half u square over a on the left hand side. You get s plus half, you can say 2a. You write this as u square over 2a, right? Equals to half a within bracket t minus u over a whole square. Now multiply by 2 over a. So we get 2 over a s plus u square over 2a equals to t minus u over a whole square. And now we'll square root it. So when you square root, you get 2 over a within brackets s plus u square over 2a equals to t minus u over a. And now you can isolate t, right? So t is equal to, taking u over a on the left hand side, we get u over a and then we have plus within brackets 2 over a times s plus u square over 2a. Perfect. So that is how you will get your equation with t isolated. So we have changed the subject to t in this particular case. Do you see that? So that is how it can be done. So with that, we have shown you how do we change the subject when the quadratic equation is given to us in the vertex form. So that helps you to practice a bit using question number 2. And then we actually modified this question. We showed you how to make t as a subject when the equation is given in standard form, which involves completing the squares and then reverse calculation. So the 2 strategies learned is completing the squares at the end, but before that, reverse calculations. So applying these 2 strategies, you can actually isolate or change subject when quadratic equations are given to you. I hope the concept is absolutely clear. It is a bit difficult. So in case you need help, you can always send an email on the address given. Also check our website for the new updates. I hope you understand and appreciate it. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.